The University of Calgary, the Calgary Health Region, and several industry, government, and community partners are proud to welcome NeuroArm, the world's first image-guided MR-compatible robot. NeuroArm can operate inside an MRI, allowing surgeons to see in real time how surgery is affecting a patient's brain. The vision for NeuroArm came from Calgary-based neurosurgeon Dr. Garnet Sutherland.
CT appears for surgery in the mid-1970s. MRI follows it in the late 1970s. Both of them revolutionized medicine because surgeons can see inside the body. Because the MR machine interrupts surgery, the number of imaging studies on any given patient was limited to perhaps 2, 3, or 4. We thought it would be wonderful to put a machine into the MR imaging space and allow surgery to take place inside a magnet. And that was the birth of NeuroArm.
To pull off a project like NeuroArm requires people from a whole variety of disciplines coming together. It brought people from the academic community, from the healthcare community, high-tech and robotics.
But before the design process could begin, one important step had to be taken.
Well, Dr. Sutherland went to visit Doc Seaman, who's a philanthropist in Calgary, and discussed the idea with him. And Dr. Seaman actually got quite excited.
My brothers and I have been involved in a number of philanthropy across the city here. This is one that intrigued us because it would have an impact on science around the world.
The idea was solid and the startup capital was in place.
Then the big question was, what company could one contact that could build a robotic system for such a harsh environment, such as inside the bore of a magnet?
The response that the team got at the beginning was that there was no company able to manufacture such a device that would be MR compatible with such high precision, image guided.
After literally searching the world for a suitable company, the NeuroArm team contacted MDA Robotics based in Brampton, Ontario.
Well, MDA is a large Canadian corporation primarily involved in aerospace sector. It's the company that developed Canadarm, which is the robotic arm flying on space shuttle.
MDA's experience with safety and reliability made them a perfect fit for this project.
There are many parallels to the type of environment that we're talking about. The space-based manipulators, many of them operate right alongside an astronaut, and any false move by the robotic system could have catastrophic effects.
One of the biggest aspects of the robot is the fact that it's MR compatible. So it can go inside of an MR machine, which gives you near real-time updated MR images.
Pretty much any material you put in an MR affects the image quality.
We couldn't use any sensors or motors that used magnetics, which eliminates a lot of them.
A lot of what NeuroArm is titanium and a compound called PEEK. PEEK is a plastic-like compound, one of the structural elements of the International Space Station. The surgeon is not only provided with preoperative images, but is given a 3D volume set from the patient at the time of surgical planning. The surgeon is also given, through a high-definition cameras, the images from the operative site projected back to the surgeon. A virtual image of the robot in space and a field camera of the entire operative site.
NeuroArm's workstation is also equipped with unique hand controllers that replicate human arm movement, providing the robot 7 degrees of freedom and an advanced feedback system called haptics.
Well, haptics, or a force feedback to the hand controller, can recreate in the surgeon's hand the sense of touch.
The controllers also improve a surgeon's accuracy.
This robot itself is accurate to less than 50 microns. A surgeon is accurate to 1 or 2 millimeters. So right now surgeons operate at organ levels. Robotics allows surgery to enter a new dimension, operating on a cell.
NeuroArm was created in an MDA laboratory in Toronto and then shipped to Calgary, where Dr. Sutherland and his colleagues are now exploring the new frontiers of this groundbreaking technology.
Robotics opens a very big door in the realm of education because computer-assisted surgeries allow playback. And because they allow playback, they also allow rehearsal.
NeuroArm will also improve patient safety and reduce recovery times.
It's going to make surgery much more precise, going to decrease the risk and increase the effectiveness of very complex surgical procedures. It's very important to have invention and innovation taking place in the Calgary area.
Because if we want the world-leading healthcare professionals, they need to be working on projects that are at the very front edge of what's going on in the world. This is a good example.
It allows the development of new technologies, new approaches to disease. And that would then foster further collaboration not only within Canada but throughout our globe.
This is what we strive for in communities and universities, bringing together talented people, creating opportunities for them to do world-class work, all done in the service of our community and the citizens of Calgary and Alberta.